All right, here we go. In 1-5, when we did day 1, I used the word inverse a lot. Okay. And basically what we're going to do is I'm going to show you how they are inverses and just show you some simple ones and then kind of show you how they are related on, and we'll probably use a graphing calculator to kind of show you that because it's just a little quicker. So as it says right there, to determine an inverse of a function, you switch the location of x and y, then solve for y. Okay. Everything else stays where it is when you do the switching of x and y. So for on letter A here, you notice x was right there and y was right there. What we're going to do is switch their location. And everything else stays. The 2 and the 4 is going to stay. So there was a y, so I'm going to turn it into an x. That x is going to become a y. Right? Stuff like this you did before. You did it in advanced math. Some of the other ones not so much. But these you did. As you can see right there, that is solved for x, not for y, and that's kind of a problem. We want to get y by itself, so subtract 4, probably a good idea. But x minus 4, you can't really put that together, as you know, so we leave it that way. And y is still not quite by itself. Pretty close, but not quite. So in other words, x minus 4 divided by 2, and I'm fine if you leave it that way. I don't need anything, is really the inverse. And sometimes the inverse will be noted as y to the negative 1, or f of x to the negative 1 kind of power. That way you can tell the difference between this graph and that graph and the relationship. If that's y to the negative 1 in this case. So you would know that those two should be inverses of each other. All right? And again, we'll kind of make that distinction in just a little bit, why that works out the way it does. So letter A, basically, let's face it, that's a line, right? And so is this, really. I could write it as 1/2 x minus 2 if I divide both of them by 2. So they'd be lines, intersecting. Letter B, you do the same thing. Here's an x, so make it a y. There's a 3, don't touch it. There's an x, make it a plus 1 to the third minus 4. So now this one's a little bit more complicated. Okay. What's probably the best thing to move first? Yeah, that minus 4 we're going to add 4 is probably your best move, right? So we got x plus 4, 3, and then y plus 1 to the third. Okay. Now what's probably the next easiest thing to, which 3? There's kind of 2 of them there. The 3 that's the coefficient or the 3 that's the exponent? Yeah, I would move the coefficient first if I were you. Because I told you I don't need these to look nice and neat, right? So who cares if we got fractions, right? If you don't need them nice and neat, it doesn't matter. Okay, so we basically have x plus 4 divided by 3 equaling y plus 1 to the third. Yep, get rid of the cube, and I'll just use a different color so I have enough room up here. Basically take the cube root of both sides, right? Agree with that, and kind of houseifies for those of you that had me for Algebra 2. So in other words, the cube root of x plus 4 over 3, again, who cares? I said I didn't care how nice and neat it was, equals y plus 1. Now here's the key, can the minus 1 go inside the radical or not? No, you can't. So it basically is the cube root of x plus 4 all over 3, and then make a very good distinction that it's minus 1 like that, equals y. And again, you could write it as y to the negative 1 because in this problem, it would be known as the inverse of the original that we had. That's how they would be related to each other. Obviously, this y to the negative 1 is not the inverse of the one over here, letter A. Okay, those aren't inverses, but it's the inverse of this particular one here. Okay. Any questions on A or B? And again, I keep making this distinction. Do you notice basically what we did to do algebra was the complete opposite of PEMDAS? We added, subtracted first, multiplied, divided, and then we did any of the powers, and then we did parentheses. I mean, it's basically the complete opposite. All right, what color haven't we used yet here? Oh, black. Green's right there.
Black.
X equals 2 to the y plus 4. Okay? So again, you kind of want to go for that adding and subtracting first if you can. We want to get y by itself. So we'll subtract 4. X minus 4 equals 2y. To the y, I should say. which it is going to be a logarithm because I want to get the exponent out of there, but you have to be very picky as to which one you use. Log base 2, because the base over here is 2. So log base 2 of this side, x minus 4 stays in there. If I take log base 2 of 2 to the y, this is why it works right here if you want to look up here. Log base 2 of 2 to the y simply becomes y. And so you've gotten y by itself. It actually works out fairly nice. So in other words, this is the inverse of, again, that one. Okay, not any other one up here, just that one. Okay. So what I would like you to do right now is you see down at the bottom there in example 2, I guess it's called, part A, I've given you a function. I'd like you to try and take its inverse right now, please, on your own. All right, let's see how you did in finding that inverse. There is a very tricky point that perhaps you forgot something incredibly important. X equals y plus 2 squared plus 4. You got to get y by itself, so subtract 4. X minus 4 equals y plus 2 squared. Agreed? So we got to now, we've kind of done adding and subtracting. There's no multiplying and dividing we can do. Square root plus or minus. Because we were the ones that decided to take the square root. It was not part of the original problem. There is no square root in this original problem. Right? And so we decided, and so there would be a positive and negative on that. Equals y plus 2 because this side housefies. Again, can that minus 2 go inside the radical? No. And again, some countries have you do that. So in this, if you're going to put a parenthesis, probably put it around the entire x minus 4. Yeah, but you can do that as well. So that is the inverse. You notice here that I do want domain and range and zeros for both. But right now, what I'm most concerned about is I would like to graph both of these. So I'm going to write them over here on the other board so that I've got them. We're actually going to graph both of them at the same time. And in fact, by the way the TI-83 works, we're actually going to have to graph 3 things, and I'll show you why. Okay. Okay. Everybody ready? Everybody understands the inverse? Okay. Hopefully I wrote them down right. Here we go. So of course you want to check this just to make sure everything looks fine here. And so we'll get out of there. So the first one we're going to do is this. So we're going to start with a parenthesis. All right, we got x plus 2 then. Remember, hit the right button for x. So x plus 2, close off the parentheses. Again, square is so common that it has its own button. You probably know that by now. And then plus 4. So that one there really doesn't cause us any trouble. But what does cause us trouble is to get all of this graphed. Okay, because really, most calculators don't have what button on it that actually allows you to put both of them in as the plus minus. So basically what you're going to do is one of them graph the plus, and then in the next one down, you're going to graph the minus, and it'll complete the graph for you. So we have to kind of do them separate. And all you have to do to graph more than one thing is just go down to y2, all right, and then type the next one in. So we need a square root of x minus 4. Close it off, and then minus 2. So is that the positive one or the negative one? Well, that's obviously the positive one, because if you look in front, it's positive square root. And then you can go down to the next one, and be careful which negative you get. It should be this white one down here, at least on mine it's white. The one that kind of means opposite, all right? And then square root of x minus 4. And then minus 2, apparently. Okay, any questions on that? They're all typed in. I think Zoom Standard is probably a good idea, because let's face it, we should know what this first graph is. Parabola, right? And really, we should know both of these as well. It's that parent graph that we know. It just has both the reflection and not. Just moved slightly, so you should really have known those. But we'll make it faster by doing it on here. So it'll always graph that. Well, there's your parabola. And there is, there's the positive. Did you see how it stopped there for a second? It did the positive one first, then it did the reflection. Well, just for fun, go back to y equals real quick. And go down to your fourth option and just graph the line y equals x. So down in the fourth step, we're also going to graph the line y equals x. Okay? Yes, be careful not to clear any of your graphs. Do you see any relationship between the first graph and the second graph and that line? It is a reflection over the line y equals x. And you learned in advanced math that basically all that happens is the x and the y values just kind of switch location. All right? So basically, and I know this probably won't work because I want it to. Oh, it did. This point basically goes right to that line and shoots out over there. Right? And why does that work? Because what did we do? How did we find the inverse? We switched x and y. That's why it ended up being the inverse. And that's really what inverses is a reflection over the line y equals x. Okay? Now, you might find out, and we're going to talk about it on Monday, what I do want you to do is go ahead and find the domain. And well, we can talk about it today. Let's go ahead and find domain and range for both of these. We'll put the domain and range up here for this one, and then down here we'll do domain and range for that one. Okay? Yeah, put these right on your paper. Yeah, get something close. Again, I chose parent graphs on this one in hopes that it would make this part kind of quicker, because you should know from parent graphs what that point is just based on how it got moved. It got moved what, left 2 and up 4? Okay, so do you agree that's kind of negative 2 comma 4 right there, right? And then knowledge from advanced math should tell you what that point is then. It's 4 or negative 2. All right? See how you got to put all this together. Okay? So anybody want to take a shot at either domain or range for maybe that parabola? Yeah, there's no problems, exactly. Domain has no issues, because if you look back at the function, see, I want you to look at the graph and the function. See, you're probably starting to catch on to that. Are there any x values that I'm not allowed to put in here? No, I can add 2 to everything, right? I can square everything, and I can add 4 to everything, all right? Now, am I going to get every single y value if I do that, though? No, I'm not, because I'm definitely not going to get any negatives because of what I've done to it. I've squared it and then added 4, so there's no way I'm going to get a negative. So how about range then? Yeah. Yep, 4 to infinity. Oops, there we go. 4 to infinity, 4. With that said, you might get really good at figuring out the domain and range for the next one. Yeah, take the range from the first one and throw it in domain for the other one. Does that actually work? Yeah. Because what'd you do? You switched x and y. Okay. And the range, again, negative infinity. Is something going to be graphed way down there? Yeah, something graphed way up there. Yes, there is. Okay. Yes. Oh, okay. Great question. She's saying the inverse, basically. In this case, will it ever really catch up to the line y equals x? No, it won't. Okay, because that slope is much steeper than this. Okay, it will never catch up. Okay. Because really, the only time the slope is really that steep is right about here, and then the slopes keeps getting less and less as you go out. That's definitely a calculus topic right there. Okay. Okay, any questions on what you've seen today? Okay. We'll take a look at the rest of those on Monday, and we'll also hand in those worksheets on Monday.